If any of you were at my talk yesterday on enterprise use cases, you'll notice my voice is about an octave lower. My voice is trying to quit on me before I'm ready, so apologies for that in advance. Thank God for microphones. Today we're going to be talking about holograms, our take on 3D interactions, and we get to talk a little bit about some of the different technology approaches. So we'll be talking about polygons and point clouds and light fields, oh my, and a little bit about our predictions of what we think is going to happen in this space. So before we get into, before we get into all the tech, I want to talk a little bit about the why. My favorite question has always been why. My kids are revisiting that on me. It's always why. But if you don't understand the why, it's really hard to get motivated and excited about the what and the how. So when we talk about the why, it was about 7 years ago, I started really focusing on the AR/VR space and looking at it through the lens of enterprise collaboration and saying, how can we do some of these experiences better? At the time, it was before hybrid work was the buzzword of the moment, but everybody was doing some element of remote work, and there was always the challenge of when you're remote, how do you have that same kind of experience as when you're in the office? It's always phenomenally challenging to have those sort of water cooler conversations and feel connected, and how can you replicate that when you can't physically be there? So we started with this challenge statement of, is it possible to get that feeling of connection? Is it possible to feel that bonding with your colleagues and coworkers when you can't physically be there, when you don't have proximity? So our approach to that was not starting with the tech, it was actually starting with the people and saying, forget about the tech for a minute, just think about how do people interact? How do people bond? How do people connect? And whether it's at work, whether it's after work, whether it's at home, whether it's at school, there are certain things that are similar through all those experiences. In general, people will come together, somebody will be sharing. Somebody will be the person who's instructing, teaching, telling the joke, whatever the case is. And people will arrange themselves around them. They'll watch, they'll listen, they'll experience. And this is how we bond. This is how we connect. It's how we form those personal relationships and alliances. And so we started looking at how do we get to that feeling when you're remote? We've all done audio conferences, we've all done video conferences, but it's very hard to feel like you're with the other person. It's hard to feel connected. So we started looking at how can we remove that barrier, that very physical barrier of a screen or a headset, or how do you get to that point where you feel like I'm not here and you're there and we're trying to connect, but we're in this together and we're just having a conversation. I know ambient compute was the big buzzword of many years ago, but I'm still a diehard ambient compute fan. I think the really best tech is the stuff that you don't notice. You want it to really fall to the background, and you want to just focus on the connection with the person and the experience there. So that's what we were trying to solve. So we focused, really doubled down on what is the essence of human connection. You may not know him by name, but Professor Albert Mehrabian, I'm sure you have seen his work in some capacity. He was a professor at UCLA. 1967, he did a study which has been quoted tons and tons and tons of times, and you've probably seen the statistic before. The most common takeaway is this 7% number here, saying when people communicate, only 7% of it is the words they're saying. So if only 7% is the words we're saying, what's everything else? So he did a lot of studies to really break into how much of human communication is nonverbal, how much is body language, gestures, expression, tone of voice, and really understanding that so much of how we interact and how we get to understanding and connection is through these things that are nonverbal. I'm Italian by heritage, and my husband likes to joke, if you pin my hands down, I can't communicate. I think part of it is this is how we communicate. It's so hard for me to talk on an audio call because when all you hear is my voice, you don't see my facial expressions, you don't see how I'm responding, you don't see if I'm agreeing with you or disagreeing with you, you don't see when I'm excited or when I'm not. Some of that can carry through in tone of voice, but a lot of it is just in our nonverbal communications. So when we started really focusing on that, we said, okay, now let's look at the tech. How do we use tech to create that experience? Cullen and myself are the co-founders of Webex Hologram. It's an end-to-end photorealistic holographic collaboration system that's really designed to bring people together. That's all it's meant to do, enable connection. So our experience is really focused on how do I get that feeling when two people are in a different location or multiple people are in a different location, how do they get that same essence of being together in a room? And how do you allow the technology to kind of fall to the background so you just focus on the person and the experience? That's what we wanted to get to. Our solution is focused on customer feedback that they were really trying to solve these two major problems. One being, I'm trying to train my staff, and they're all over the world, and time is challenging, and travel is challenging. How do I get that feeling of just, hey, let's just sit down in a room and let me walk you through it. Let me show you how this is done. So that was one use case. The other one was around remote design reviews, where you need to get consensus and sign off on something that's very important. You need to understand all the different facets of something. You need to be able to interact with that and really see, are people agreeing with this? Am I communicating understanding? Are they coming to my point? And so that was the second use case that we focused on. And it was really this, how do you bring your authentic self to that experience? I like to use the example of our product manager on the solution. When she first started and she demoed the experience, she's used to doing video calls all day. She works remotely out of Galway, Ireland. When she first put on a headset and participated in this experience, she said her immediate reaction when she saw one of our colleagues from Norway appear in her office in front of her, she's like, I felt like I needed to tidy up. I felt like he was right there. So that's what we're trying to create, that magic of feeling as if you are together with another person interacting. Ultimately, it's all about connection. That's what we're trying to create. So we are going to talk a little bit about the technology, but I want to keep that in mind as we go through that because it is all about enabling that experience and enabling that connection. So I'm going to pass it off to Dr. Jennings to walk us through some technology.
Thank you. So it's been an exciting project to work on, and as Elizabeth set up, the requirements are incredibly high here of trying to figure out what is it that allows us to have that connection. And when we start building all of these AR and VR type experiences and bringing them together, every time you don't get the details exactly right in the image, you don't create the model in your mind of what your brain expects, and your brain realizes something's not right. And that's where we start to get the motion sicknesses in these applications, or it just falls apart as an illusion. So we worked really hard on figuring those together. I'm going to step through a little bit some various approaches that we went through and used and have been used widely by others, and talk a little bit about them, some of the pros and cons of them, and where we went on them. Keep an eye on the time too. So probably one of the most common things that's used for a lot of these applications are texture map polygons. And this is really good for bringing in like virtual models that were created with a CAD/CAM system or some sort of other application. There's also lots of systems that try and use some sort of depth camera or series of depth cameras and scan the environment and create these types of objects in real time. Those objects always end up with a bunch of triangles, which are showed on the gray side here, that then have color and texture mapped on top of them, which creates an image like the shoe. And you can rotate them around, see them in 3D, you can look at them from different points of view. But they're always a little bit bumpy. They don't have quite the right level of detail on the highly automated scans of them, particularly one where you're trying to capture a person at 30 or 60 frames per second. You don't get those sort of level of details. And that really fell apart. And you start to see holes in people's hair and eyes and those types of systems, and that defeats the whole illusion. So the next one we use that gets a better level of detail that we've seen in a bunch of cases are point clouds. And the idea here is, instead of getting a bunch of polygons, instead you capture and scan in real time a person or an object or a scene, and you get really a lot of points, 3D points, that are located with a particular color at a particular location. And these types of systems typically use more cameras than the polygon scan type systems. The compute's a little bit harder, but the detail gets a little bit better. You can start to see that in some of the areas of the shoes and the shoelaces, and those types of ideas will be somewhat better. Now, none of those really got to being able to capture the type of things we wanted, where we really had all the nuances of a person and at the same time might have an object that they're holding in front of them or something. So I need to tell you a little bit about light clouds, because people don't know enough about light fields and how light fields work. So the idea of a light field, it's not a new idea. This idea has been around in literature for well over 20 years, and there's been various implementations over the time. What's changing now is the compute level that we have in GPUs and modern systems has made it possible. A lot of the other research on compression, various ways to deal with calibration has made this practical. So what a light field is you try and understand what every ray of light in the room, what color it is. So you can think of any point in this room right now. It's got light going through it from every different direction, and every one of those rays of light has a different color. Now, if you knew what all of those colors of every ray of light in this room was, and you were trying to take part of this room and put it into a metaverse or use it that way, all you would need to do once you knew the colors is figure out where the user was, and then figure out what rays of light are going through their eye and reproject those. So that's the basic idea of what a light field is. And the way we capture them, there's many ways of capturing, but the way they're generally captured and the way we use is an array of cameras that then, every one of the rays of light eventually hits one of the walls. And at the wall, it hits some camera, and you can sample it. A lot of technology around interpolating, so you need less cameras, figuring out what all the rays of lights are from various places and calibrating the cameras. But that's the basic idea of light fields. So here's an example. These images are taken out of Webex Hologram. They're shot from inside an actual headset, and they're looking at this viewpoint from two different the heads moved from one point of view to another. Time slightly different too, because we couldn't capture them at the same time from one headset. But it's pretty much the scene hasn't moved. Now, this has objects like a glass of water, and that is an incredibly complicated object to represent accurately in these types of systems. If we put that as polygons, the problem is you're seeing through it, and you're seeing images through it. And what you see through it changes as you move. So as soon as you're moving, the whole image changes. And it turns out that almost all of our images have some components in them that are like, like the specular skin on the reflections from these lights sort of change as I move, and you're looking at them from different points of view. And getting those details right is really important to have an experience where you just actually feel like it really is that person sitting in front of you, projected as a hologram in an AR headset. So that's critical, and the water is a great example that sort of highlights the problems of doing this with point clouds or polygons, because the polygons or the point clouds can only really represent easily one color at a given location. And unfortunately, we need different colors at that location depending on what angle you're looking at that location from. And that's where the light fields really shine, is they allow you to show different colors when you're looking at it from different points of view. So that's sort of the approach that we have taken through this whole system. We do a lot of technology to capture all of it, send it over a sort of normal broadband connection, compress it down, and bring it forward. But we're excited about that type of approach to bringing it forward. Our product's based on that. People are welcome to see it if they want at some point. But really, I want to talk about the range of those. So let me jump into a bit of a comparison of these. So before I go any farther, I always get the question, why aren't avatars on this slide? And avatar technology has improved dramatically in the last 5 years. Certainly, if you go back 15 years, it's just infinitely better than it was then. Every single avatar technology that I've been able to demo or use or play with has not come even close to meeting the basic question that I want to ask and when I'm communicating with someone, like, does this person understand me? Are they confused? Do I believe them? Do I trust them? I mean, if you can't decide whether you trust something or not, it's not really very good for the type of tasks I'm interested in doing of bringing people closer together. There are use cases where basically you want to hide your identity, you want to change who you are and those types of things, and avatars are tons of fun for that. I mean, like everyone can be a furry in Second Life. I'm not saying there isn't a point of view for that at times. But for these tasks of bringing people together, communicating about something, understanding what you're saying, and coming to a decision together in consensus and understanding the subtleties of people, we haven't seen any avatars where the avatar accurately represents even what a 2D video would have done of someone. So we haven't really compared into those yet. I'm sure they'll improve over time. I would say that all of these have a range of, as we go from the sort of captured polygons to the point clouds to the light fields, the complexity and the data requirements go up, but the fidelity and resolution goes up, and the type of objects they can do really go up as well. And some of these things like data size, fidelity are really important. The other thing we look at and found was really important in these systems, if you're evaluating them or building them yourselves, I'd encourage people to look at what happens when it goes wrong. When there's a capture artifact, how bad is it? So a lot of time on the polygon ones, where you get like a little second where a spike comes 3 feet out of the side of your head and then disappears on the next frame or whatever. That's really distracting from a user point of view in interacting with those things. So how they're robust in damaged areas is important too. Translucent objects, reflective objects, talked about those, and real-time captures. Obviously, low latency real-time capture is critical for communications. And we view the limit for that to be in the few hundred milliseconds sort of order of magnitude, which we easily do, and that's a real key part of the system as well. So that's a bunch about the tech of this, and I wanted to just sort of, with Elizabeth here, talk about some of the things we see going forward.
Yeah. Jumping forward to our next one. There's so much potential in this space. There's so much opportunity. And a lot of it we haven't figured out. But we have our own theories and predictions of what we think is going to happen in here. One being curated experiences. I think right now everyone's trying to say, what's the metaverse? What does that look like? And define it as if it's a single thing. It's not a single thing. I think there's going to be very different experiences depending on what you're trying to do. What is the experience you're trying to create? Whom are you trying to connect with? What does that look like? And I think we'll see a lot of different paths forward of that as things will be curated for the experience you're trying to define in that moment.
I think that the interoperable content is one of the things that I think is really important. I mean, if you think of the average web page in Web 2.0, you can embed a YouTube video on that page. You can bring various content from various websites together. There's a way to bring it together and it all interoperated in one space where you browsed it. I think we need the same thing in a 3D world. We need to be able to go into some 3D space as a metaverse, whether it's AR, VR, I don't care, and we need to be able to bring the content. We want to bring the live content of humans and collaboration into that, but we also want our design partners to be able to bring in their design tools and whatever content they're creating, and there's going to be different ones and they're going to have to work together. And I'm not a big believer in there's going to be one platform that does all of this. If we just all built our stuff on top of one company's stuff, it would all be fine. That's not the model that worked on the internet. The internet was a way about federating and bringing things together. So I'm looking for that type of interoperability. I think that's going to be really key for the future. Magic Leap really covered that well in their keynote this morning. They really nailed some of those same key points about interoperability and what was going to take there.
And I think with the Metaverse 2 predictions in there, I think the short term, it's going to be much more focused on AR than VR. I think Peggy Johnson from Magic Leap has said this multiple times, and I very much agree with her thinking, is that bringing virtual content into my physical world, that's phenomenally compelling. And that's something that I think in the short term, that's what the Metaverse means to me, is bringing virtual content in my physical world. Longer term, I think we're going to have opportunities to go into virtual worlds and create those different curated experiences and have interoperability so you can bring things from one experience to another. But in the short term, I think it's very much an AR play.
Okay, are we done here? Ready for questions?
Sure.
So from the audience, there's 2 mics out there. If somebody's really close to me, I can pass them this one. Please stand up, go to one of the mics for questions. For Cullen and Elizabeth.
Or your own theories on where the metaverse is going.
Ask us anything.
Yeah, I just have a very quick question. Can you give a sense on how many cameras and what kind of setup is needed to create something like this? Does it, yeah.
Would you like to take that, Dr. Jennings?
Oh, thanks. No, it's a good question. So we get this. So basically, as we use more cameras, we can capture a wider field of view. So it depends on the use case application. But what we're trying to do is bring out something that captures people and objects for common design reviews. That's a small enough number of cameras. So we're looking at different use cases, but a handful or more of cameras, not a full 300 of them all around you. It's a handful of cameras that brings out a product that is comparable with today's high-end video conferencing systems from a price point of view and a complexity point of view in installing. Because like these systems that have a full sphere of cameras around you, that's not something you can just put in your conference room and go use or put on your desk at your house and use. Right. So this is very much bringing out a product that would work in a classic enterprise sense with a handful of cameras that can capture the images that you saw up there.
Okay, and I believe there will be some compute sitting there to process all the data before it goes to the cloud.
There is some compute with the cameras for sure. We use a lot of NVIDIA GPUs. And then that goes up to the cloud where we use a lot more GPU in the cloud. We collapse the light field. We're very proud of our sort of compression and data rates we can achieve. And then we will bring it down to a headset. So today we're on HoloLens 2, Magic Leap 2 headsets. And then there's some more compute on the GPUs on that headset to go and do it. But that's the three chunks of hardware that are involved in the solution.
Okay, thank you.
Hey, I was just wondering if you've seen this used in a training situation and if there's been a measurable improvement having these realistic holograms and even just having a person hologram there to do the training versus having it as more of a standalone training situation.
Yeah, absolutely. Our very first customer that started using this in our trials program was a medical devices company that was using it for training. And it's very challenging to teach a remote staff how to use a piece of equipment when you can't show it to them and they can't pick it up and experience it. So for them, their main challenges were all the complexity of flying somebody on site to do training or having to try and do it over a 2D flat screen, and it's really hard to show spatial awareness and multidimensionality with that. So they started using it for training on their medical devices and did see an impressive difference in how people would interact, because it's more the same way as if some trainer was there in the room with them. They would have that same type of experience.
And it works perfectly fine with that.
HoloLens 2 and Magic Leap 2, we were supporting both of those. We're trying to say fairly headset agnostic in that.
Okay.
The experience will obviously differ by the headset, because each headset has its own specs.
Great, thank you.
Let's see, we have time for one more, as long as it's not too big.
Yeah, my name is Simi. Thank you so much for the wonderful presentation. This is very exciting. My question is there currently a use case for events, having a hologram use case for events like this or conferences? It might not even be a conference, but events. So I'm in my house and I can attend this event from my house, using the technology of holograms.
Yeah, we've looked at that, and there are other solutions that are addressing that right now. Where we started, it was really based on what our customers were saying they needed. In that case, it was much more of those targeted, high-profile training or review scenarios where it's more of a one-to-many with 3, 5, 10 participants. And you really need to have that feeling of being together with them and that back-and-forth interaction. We are very open to future use cases, though, depending on how our customers want to take it.
I'll add a little bit to that, too, of that
Colin, now,
Go.
we need to close off this session
Thank you.
so everybody can get to their next one. Thank you very much, Colin and Elizabeth.
Thank you all. We'll be around later if you want to catch us.